All right, I'm just going to collect homework. All right, it's the mini review. I'm not going to collect that homework. We're going to move right on. Here's your homework for tonight. Not collecting the mini review. Just stay on. A lot of stuff today. A lot of stuff. One new formula. It's very easy.
Yeah. So, not do.
Because it was literally exactly like the Now, with the exception, I think the last 4, they were all like done within 2 seconds, but the last 4 took a little bit of time. All right. One formula today is ridiculously easy. It is, believe it or not, it is confused by many students. Many students, myself included, when I first learned this, it's confusing, not in what you just do, but which one is, well, I'll tell you where the mistake comes when we get to it. We good? We got homework copy down? All right, here we go. Inscribed angles. We've actually seen these before. They've been on the sheet. In fact, they were on the quiz. You just didn't know they were inscribed angles. All right. Many concepts today, although they all revolve around this thing called inscribed angles. All right. Each thing that I show you is incredibly easy. However, taken all together, that's where the confusion comes. Danny, put the calculator down. And pay attention. Here we go. When we put all the things together, that's where we get a little bit of confusion. So be careful. So pay attention, take great notes, ask questions if it's something you don't understand. All right. I already showed you this once. I mean, every single day until the end of the, it's a lot of stuff every single day. So put together without a resource card / book of truth, boy, you can get lost in the stuff. You did fine on the quiz you just took because it was in your book of truth and you practiced for the test or the quiz. That's why you did well on it. For those of you who didn't do well on the quiz we just took, well, I'm just saying the way you succeed in this class is you do the review sheet, you ask questions, and you make sure everything is in your book of truth. Here we go. Hey, recall, circles. What did I just make? What did I just make according to this chapter? I made a major and a minor arc. I also made a
unevenly cut pieces. An inscribed angle.
I did not make an inscribed angle. I made a central angle, right? Angle 1 is a central angle. When you make a central angle, you do make, in fact, arcs as well, or you cut arcs. But yes, I was trying to get to the central angle right here. Okay, great. You got a minor arc. You also have a major arc. Remember, major arcs have 3 letters. I didn't put a point over here, so I'm not going to name the major arc. But when you have a central angle, you do, in fact, make arcs. Okay, the measure of angle 1 equals the measure of arc AB. Nothing new there. All right, here comes the new stuff. You ready? There's a lot of stuff. Here it comes. All right. The key to understanding this is you're looking at the board and you're paying attention. First idea is this. And like I said, everything I'm going to show you is easy, but in totality, it's confusing. All right. Instead of the center of the angle, previous one, instead of the center of the angle being at the center, I'm going to move the vertex of the angle to on the circle. If you remember section 9.1, I gave you this picture, except I put a triangle on the inside. And I said, if the shape is on the inside, we call it inscribed. What's the shape this time on the inside? It's an angle. So this is called it's called an inscribed angle. Angle 1 is called an inscribed angle. There's nothing, we'll write the definition down here in a second. But that's the idea. The difference between a central angle and an inscribed angle is the vertex is on the circle. Write this down, please. Inscribed angle, book of truth. It's an angle whose vertex is on the circle. Here's 2 examples right here. It's an angle whose vertex is on. Remember before, central angle, the vertex is at the middle of the circle. But just like a central angle, well, it makes chords. It could make a minor chord, It could also make a major chord. Pretty simple concept, right? Today we will be saying something about the inscribed angle and the arc it makes. We're going to get a formula. Hey, what's the formula for central angle and the arc it makes? What's the formula?
An easy one that I don't remember, but it's inherent.
They equal each other. If this was a central angle, angle 1 equals the arc measure, right? Inscribed angle, not true. Angle 1 does not equal this arc anymore. Okay? So there's a relationship, and it's an easy relationship and easily forgotten.
Is it double that?
We'll see. All right. So there's an inscribed angle. I made a minor arc. There's an inscribed angle. I made a major arc. You don't need to draw that, but you just need to understand that it does make arcs. We good? Okay. Moving on. Quick notes. There's nothing special about this. I'm just showing you. If your inscribed angle, one of the rays goes through the center, guess what the arc must be? No. Listen to what I'm saying. If your inscribed angle, one of the rays goes through the center, guess what the arc must be? It's got to be minor. Okay? If the two rays, neither one of them go through the center, guess what the arc has to be? Well, clearly this one is AC is major. No, AC, remember, major means more than 180. Is that arc more than 180? However, I could open these legs up so it could be major, right? So if the two rays do not go through the center, it could be, finish the logic. Well, this one's minor.
It could be
So it could be, finish the sentence.
major or minor.
That's the answer. Okay. Lastly, if both rays are on one side of the center, guess what the arc has to be? It's got to be minor. Okay. Book makes a big deal about this. I'm going to show it to you, and we're going to let that sleeping dog lie. Right? Great and all that stuff. We don't get formulas from this. Okay, but we do get some conclusions. All right. What is all this good for? Well, we got to do a proof before I say here's the formula. Here we go. Hey, what do we have? What's the shape? Okay. We have a inscribed angle inside a circle. Okay. I'm going to prove that the relationship between the angle, inscribed. Dang, what are you writing? Okay, good. The relationship between the inscribed angle and the arc, this is what we're going to prove. That the angle is a half of the arc. That the angle is half of the arc. Angle, half of the arc. I told you it's going to be easy. It's hard to remember, where does the half go? Does it go on the angle or does it go on the arc? It goes on the arc. The arc is a half of the angle. All right, let's prove this sucker. What?
The arc half the angle?
The arc is half of the, no, you said it backwards. Take half of the arc, you get the angle. Take half of the arc, get the angle.
Got it.
Okay. So that's what we're going to prove. It turns out this is not a really challenging proof. We do have to make some constructions. Okay. I'm going to make, because we like circles, and what's the favorite thing we like about circles? We like radii. I'm going to make a couple radii. In fact, I'll make one. See what I did? Therefore, construction. OA is a, what's OB? So what's the shape of the triangle? If they're both radii, then the triangle must be, the triangle has to be an isosceles triangle. Okay? Both radii are congruent, therefore it's an isosceles triangle. Cool. All right, now we notice the really small text. It is going to take us a while, but it's an easy proof. If it's an isosceles triangle, and we know that these two sides are congruent, what can you tell me about these two angles right here? They're congruent, all right? So what I'm basically saying, I'm saying that this angle is congruent to that angle.
Excuse me,
Yes, ma'am.
can I have Ethan for a moment?
He's on his way. We good? The logic?
Okay.
Good. Next statement. I'm going to say that two of these is equal to one of these. Where in the world am I getting that from? Two of these, angle B, equal one of these. And I'll put a dot what I'm talking about. AOC, see that? I'm going to say two B's equal what? Where am I getting that from? We haven't used this in a while. Triangle, external angle. What's the relation between the external angle and the two remote angles?
Oh, they add up to. Oh,
They
yeah.
add up to each other, right? I take the two remote angles, or two remote angles, and they add up to the exterior angle. But wait a minute, what kind of triangle is it?
That's awesome.
Therefore, this plus this equals two of these, or vice versa, right? Because they're the same. So 1 plus 1, they're the same angle. That's a 2. So this angle is equal to 2 of it. I could have said that one as well, too. I'm choosing this one. You'll see why here in a second. Okay? So that's the logic of this next statement. Okay? Two of these angles, A, B, C, equals one of those. All right, cool. Why am I saying that? Because I'm trying to get an ABC. Hey, I got an ABC. I'm trying to get an arc AC. Well, I got an angle. And what do you know about this angle right here and the relationship to its arc? They're the same. So AOC is equal to it because it's a central angle. I got a 2. What do I want to get?
1/2.
Just guess what you do. Divide both sides by 2. Okay? So if I divide both sides by 2, there's my half, but it says AOC. I wanted to say arc AC, but we're in luck because AOC is a central angle, and the central angle equals the arc. So I just use a little bit of substitution, and I'm done. There we go. I proved it. You want to know the hardest thing about this? Is remembering which one is the half. Okay? So Matt, you remember?
Yes, the angle
Is
half of
the angle is a half of the arc.
I'll say
The only way I remembered this, right, was the fact it's alphabetical. Angle, AN, comes before arc, AR. The angle is a half of the arc. Okay, there's one way of remembering this. The angle is a half of the arc. I'm making a big deal about this because kids make this mistake all the time.
that angle is smaller than
Yeah, and the other way, I'll show you the true way that I remembered in high school. It wasn't that, but I throw that out there for people to like alphabetical things. Oh, by the way, write this down. There's just 3 depictions of it from the previous one. So this is 9-7, and it basically says that if you have an inscribed angle, that the angle is a half of the arc. Angle, symbol, arc symbol. Central angles are equal. Inscribed angles, the angle is half of the arc. Another simple formula. Can you forget this one? Oh, heck yes. Like, wait, is it double? Is it half? By the way, if we want to multiply both sides by 2, you get another formula that 2 angles equals 1 arc, if you like that one better. I'm going to stick to an angle is equal to half an arc because it's clear in my mind. That's not hard. That's a pretty simple one. Give me the arc, take half of it, you got the angle. Give me the angle, double it, you got the arc. But you got to remember which one's half, which one's double. And it's easily forgotten. All right. Hard to remember. Here's a second way if you're a visual person, not a word person. If you're a word person, put it alphabetical. Angle is equal to half of the arc. If you're a visual person, all right, hey, what did I just make? Chord that is a diameter, right? I'm going to make an inscribed angle that touches the 2 corners, right? Guess what that has to be all the time? This is right, but the arc it makes is equal to, so this would have to give me the relationship, because if that's 90, now it's clear to see that the arc, take half of it, and you get the angle. The angle is a half the arc. If you're a visual person, you can always draw this, like which one's half? Okay, the angle is half of the arc. The arc is double the angle. If you're a visual person, remember it this way. If you're a word person, then alphabetical angle is half of the arc. Okay, there's my two ways of remembering it.
Angle is smaller than.
Agreed, but you got to draw it though, right? Okay. Oh my God, look at that monstrosity right there. It's a lot. Okay, let's see if we can figure this one out. What do they want us to find? They want us to find an X. They want us to find us a Y. This is box 2, everybody. Box 2. Danny, you with me? Danny, what do you want to solve for? X or Y? Let's look at X. So sometimes you have to declutter the picture. I'm trying to ignore everything but what's involved with the X. There's a lot of stuff there. But if you can declutter, X is red, so declutter the blue from the picture, what are you left with? Well, there's X. There's the arc. What's the relationship between angle and arc? What? Did you write this down? Hey, in your theorem, 9.7, literally the previous slide, it says that the angle is half of the arc. So it's 20. Well, that was pretty simple. That's a crazy, ugly picture, and it ends up being a simple thing. Wes? Well, we just found out that X was how big?
20 R, Y is 60.
Well, how are you getting that from?
Because PQ is 40 and R, major arc PR is 100.
Oh, that was solidly well done. Do you see where we got that from?
I did that in like the first.
Now we got to declutter and look at the blue. Well, the blue starts off at 50, so we know that PR has got to be 100. Well, the only thing we're missing is Y, and we know that that piece is 40. Well, that gives us 60. Well done. Sometimes, a seemingly complicated picture ends up being pretty simply done. All right, here's all those words that you guys just said. We good? Honor, you see the logic? For the issue is, like I said, remembering which one is the half, whether it's the angle or the arc. The angle is a half of the arc. Okay. Write this down. This is a corollary. I can prove this one really quickly. Declutter the picture. Look at the red. Declutter the picture. Look at the red. What's the arc that inscribed angle makes? What is it? Declutter the picture. Now look at the blue. So they basically make the same. Therefore, if they're both inscribed angle, what's the relationship between 1 and 2? They got to be the same. They got to be the same because they describe the same arc. That's what corollary 1 to 9.7. There's going to be a lot of these. If two inscribed angles intercept the same arc, in other words, they construct the same arc, well, then those angles, the inscribed angles must be the same. There's no half, there's no anything. We're just saying they got to be the same, 1 and 2. The issue is that generally what they'll probably do is they'll say that AB is 40 degrees. And then they'll say, well, how big is 1? Right? Type thing. They love this theorem. Like, not necessarily that you got to call it out. But they love that construction right there. Guaranteed, tonight for homework, there's one you're stuck on. And you're like, well, I'm looking at the red. I don't know how big it is. Try to see if there's another inscribed angle that actually describes the same arc. They love this one. And it'll be some weird, complicated thing. You're like, well, I don't know how big it is. And then off to the side, you won't notice it because it's a really messed up picture. You'll say, oh, wait, there's another inscribed angle that's going to the same arc. Therefore, they have to be the same. Clear as mud? Okay, this one's an easy one. Okay. So if both angles make the same arc and they're both inscribed, hey, if one's a central angle, doesn't work here. but they're both inscribed and this does work. Corollary 2. I just showed you this. Hey, think about this. I don't even have to prove this one. This one's easy. A diameter makes how many degrees for the arc that it cuts? 180. Well, it's an ascribed angle, so half of 180 is, well, you just proved it. Okay? So corollary 2 just says this. If your inscribed angle makes a diameter, they don't say that, they say semicircle. If your inscribed angle, the arc is a semicircle. I think of it more as if the inscribed angle touches a diameter on its endpoints, right? Well, then it's got to be a right angle because half of 180 is 90. They love this one too. They will leave off the square. But when you look at your inscribed angle, oh, wait, look, it's touching a diameter. It's got to be 90. They love that one. All right, I said each one is pretty easy. We've got a lot. We're halfway through right now. Jenna, you online? We good to move on? Okay, moving on. All right, if there's one to forget, it's this one. What do you see, Ethan? Could be, but clearly it's at least the red part.
Yeah.
It's I don't think it's a trapezoid. Could be. So what kind of polygon? How many sides does it have? So what do we call a four-sided polygon?
Square.
It could be a square. What do we call a four-sided polygon? Because that's what this was going to use. Quadrilateral.
Yeah, it was.
If you have a quadrilateral that's inscribed in a circle, this is hard. It's really easy to prove. Watch the magic. You ready? You see E and G? That is made by inscribed angle H. You see that? What about F? But this one goes to here. This one goes to here. How many degrees in a circle? And inscribed angle is half of it, right? What's half of 360? Really? What's half of 360? I'm throwing things at you. All right. Now, we're okay right there? Both inscribed angles put together, in other words, summed together, would be the entire circle. But inscribed angles are half the arc. Half of 360 is 180. So what's 1 plus 2? No. Inscribed angles. If the arcs added together is 360, then the angles added together must be 180. What's the relationship when we add two things and we get 180 called? No. They could be, and that's true for a square. What do we call when the relationship with two things add up to 180? You got it? Supplementary. So we just proved this, by the way. Right for homework, I think they have to do that proof, but there it is. So if you have a quad, doesn't matter. It could be a square, it could be a trapezoid, it could be a kite, it could be this ugly thing right here. Now be careful what it says. It says opposite angles. Not adjacent, but opposite angles. Adjacent, not true. It could be true if it's a square or a rectangle. But for just any quadrilateral, opposite angles are supplementary. Opposite. So that means you take two opposite angles, you add them together, you're going to get 180. This one is forgettable. The other ones are kind of self-obvious. This one is not. We just did prove it, by the way. You got a quadrilateral that's inscribed inside a circle. Take opposite sides. They add up to one. And we're talking about the angles, not the arc. The arc is 360 from G to E over there, plus E to G over here. That's 360. But remember, inscribed angles are half of the arc. you get 180. They're supplementary. We good? We have it all written down? All right. This one's going to be challenging to understand it, but it's really easy to do. Oh, look at that mess. By the way, what's inscribed there? What do we know about quadrilaterals that are inscribed? Their opposite angles are supplementary. So I already know that angle C plus angle A equals angle C plus angle A equals 180. Okay? So let's see if we can figure this out. One piece at a time. What's the first angle I got to figure out? BCA, right? Where's BCA? BCA is right here to right there. So I'll put a 1 there. There's angle 1. That's what we're about to calculate. How big is angle 1? Where are you getting that from?
It's got a 30 and it's 90.
Because it's what?
Because it's 90, right? They're supplementary.
Well, why would it be 90?
Well, because
It could be 20, and then the other one adds up to 180. So a bit more challenging. This is why you got to declutter the picture. You ready? I said it's challenging but easy. Watch this one. You're going to not be happy. What arc does angle 1 make?
Oh,
Declutter. Is there anything else up there that also makes arc AB? You got to be able to declutter the picture.
ADB.
What is it?
ADB.
And what does it say ADB is? Wasn't that easy? Now, where did we get that from? Once again, remember, angle 1 goes to AB. We see if there's any other lines that go to AB that has a number, it's 40. There's no math involved. So it's 40. Okay, I'll label it. Hey, now I already know what angle A adds up to. 40 plus 30 is,
70.
therefore, all of angle A would add up to 110. Okay, what's the next one it's asking for? ABC. Oh man, why are they doing this to me? Looks hard, and this ends up being easy. Can you see it?
No.
What arc does ABC make?
CDA.
And what do you notice about that arc?
40 degrees.
Where does it go through?
Diameter.
The diameter. So therefore, it's got to be 180. That was easy,
That was not easy at all.
right?
That's what I'm saying.
Oh, by the way, that's what the arc is, 180, but the angle is half, it's 90 by that corollary 2. So all of angle ABC is not 180. The arc is 180, but the angle is 90. All right, we're tearing this one through. The last one is bad. I get it. There. All right.
That's hilarious.
Okay, we know that's 40. We know this one, this whole thing right here is right. Now we're going to try to find BAD, and we're going to get that from this right here. So you told me the whole thing is 110, and we're done. All right. A seemingly very challenging problem, and it is, like, I'm not going to lie, it's challenging. But each individual piece, when you finally see what it was, we didn't do anything here. Oh, it goes through a diameter, it's 90. Okay. Once you see all the steps, then you're like, okay, it's not as bad as it seems. What part? We're okay with that being 40?
Yes.
What do you know about opposite sides of a quadrilateral that's inscribed in a circle? That 40 plus 30? 180 minus 70? Because they're supplementary. 110. Yes?
Yeah.
Okay. All right, last idea, think about this. All right, look on the board. Hey, inscribed angle, yes?
Yeah.
Here's what I'm going to do. I'm going to take TB, I'm going to make it larger and larger and larger and larger. You ready? I'm not claiming how many degrees it is, I'm just making it larger. Hey, tiny angle, yes? Angle is half of this arc. All right, hold on, we're almost done. Last thing. Make it bigger, make it bigger, make it bigger. Eventually, it's off the circle, and it is a tangent.
What I say?
Now stay with me. If it went through the center it would be 90 degrees. It doesn't go to the center. So what can you tell me about this angle? Well, it may be, but well, clearly it's not. The only way it's a right angle is if AT.
He said clearly it's not, because clearly it's not a right angle.
So clearly it's what? Bigger or smaller than a right angle? It's smaller than a right angle. You need to write this down. Last theorem.
On the army goes.
Okay. It doesn't look like this, but it's true. Let me explain it to you. You see AT? That's the arc it makes. And it turns out that that arc is going to be half of that angle. You're like, isn't that the same theory? Well, we don't have an inscribed angle anymore, right? Because one of the rays is off the circle. It's not inscribed anymore. T is inscribed, but now one of those rays is off the circle. Like, why does this need another theorem? Why? Because this ray is not inside the circle anymore. So this one, according to the math gods, needs its own theorem. Hey, is this any different than the other one? Does it still say the angle is half the arc? Does it still say that? It does. Cool. That was the last one. You got it written down? Everybody? Connor, yay, nay? All right. So we didn't get to the actual answer. You can probably do this real quick. This is 140. Angle T is 70 degrees. Done. Pretty simple. Exactly. All right, we made it through. Was anyone live today? Jenna was not live. All right, Jenna, if you have any questions, send me a chat or email. Catch you tomorrow. The quiz was posted. Like everyone else, take about 10 minutes to take that quiz. Make sure you submit it on Teams. I will see you tomorrow.